Alright, today's lesson is about reflections. There are a couple of different reflections that we talked about in class. We talked about a reflection over the x-axis, a reflection over the y-axis, reflections over the line y equals x, and then reflections over y equals a number or x equals a number. Alright, so we're going to look at a couple of examples. The first one we're going to look at is one of the reflections over an axis. So there's two ways of doing these. The first way is the shortcut method, which if you can remember the shortcuts, they work really nice and it makes your life really easy. For people like me who don't remember shortcuts very well, I'm going to do these out for you so you can see exactly what the process is. Alright, so our first problem asks us to reflect points P -1, -1, Q -2, 1, and R 1, 1 over the x-axis. So, first of all, it's giving us an instruction. It says reflect, okay? Second of all, it gives us the points we're working with. And last, it's telling us where to reflect. What I do is I identify what my line of reflection is. So here it tells us the x-axis. And I can see that this is my x-axis right here. So I am going to highlight it. Okay, I'm going to make it dark green so that way I know that that's my line of reflection. Next thing I'm going to do is I'm going to plot the original points, my pre-image points. So -1, -1 for P is right here. -2, 1 is right here for Q. And 1, 1 for R is right here. I will connect all these. It should make a little triangle. Okay, and the directions tell us to reflect over the x-axis. So, what I'm going to do is I'm going to look at my points. I'll start with P. I want to try to figure out how far away from the line of reflection I am. Right here I can see I'm only 1 unit away from that line. So, to be reflected, it would mean it's on the other side of the line, and I want it to be equally distant. So, if I'm 1 unit away on this side, I have to make sure that I'm 1 unit away on the other side, and that's where my new point P prime comes. Next one I check is Q. Alright, so here's my line of reflection. Q is right here. It's also only 1 unit away, so to go on the other side of our line of reflection, that's going to be Q prime. And our last point, R, again, it's only 1 unit away, so if I go across the line of reflection, we would be 1 unit below. That gives us R prime. Connect all of my points, and there I have the reflection across the x-axis. Y-axis is very similar. The only difference is our points would be going from one side to another rather than up and down. Second problem, this one's talking about the line y equals x. Again, if you remember the shortcuts, use them. If you're like me, we're going to have to figure out what the line y equals x looks like. Well, easy way to think of it is, no matter what x is, y has to be the same. So if I plug in the value of 1 for x, I would have to get out the value of 1 for y. Right? So that would be that point right here. And if I plug in 2 for x, I would get 2 out for y. And if I plug in 3 for x, I get 3 for y. So you can kind of see that the line of reflection is just going to hit all of these corners of all of these boxes. So that's the line y equals x. Okay, so now I have my line of reflection down. I'm going to plot my points. They give me A 2, 1, B 3, 0, and C 0, -1. So let's plot those real quick. 2, 1, 3, 0, and 0, -1. And I'm going to connect all of those. Alright. Here, we should notice that we can't just count directly over to the line or directly down to the line. It's not going to work like it did before. However, what we can do is we can count diagonals across the box as a unit. What I mean is this. Let's look at point C. point C, if I was to go from point C directly to that line, I'm only crossing half of a box. So on the other side of that line, I want to be going half of a box. That's where my C point ends up. A is very similar. A is only half a box away, going diagonally, so I want it to be on the other side of the line, half a box away. That's A prime. B prime, I see, is 1.5 full boxes away, so I want to go 1.5. On the other side, that gives me B prime. Connect all of my dots, and that's the reflection that we get. Okay, our last problem. This is only a single point. It's not a full triangle like the other ones. However, this one tells us that we're going to reflect over the line y x equals 1. Okay, so the line x equals 1. Where is that line? Well, if I think of it this way, no matter what my y value is, I'm always going to get 1 out for x. So that means I always have to move it to this spot right here. And it doesn't matter what my y value is, it's still going to end up right here at x equals 1. So that's my line of reflection. Then I want to plot the point they gave me. 4, 2 is over here. 4, 2. That's point P. And now we're back to easy counting, right? We can see exactly how far away from that line we need to count. I can see it. I'm 1, 2, 3 units away here, so I want to be 3 units away on the other side of that line. So 1, 2, 3 would put point P prime right there. The only thing we have to worry about is writing our answers in the proper notation, transformation notation. So for example, this problem, we would say P, which started at 4, 2, went through a transformation, that's what the little arrow is. We end up at P prime, and its location is -1, -2, +1, +2. And that's how we would write our answer in transformation notation. That's how we would show our answer on a graph.